Not every machine is born in a spotless factory or from expensive blueprints. Some are built from real needs, quiet curiosity, and hands willing to learn by doing. In this video you'll be guided step by step through the process of building a homemade welding machine. Simple in design, practical in use, and reliable enough for real work. This is not just about assembling parts, but about understanding how the system works, choosing the right components, wiring it safely, and avoiding common mistakes that cost time and money. If you believe a tool is only truly powerful when you understand it inside and out, this video is where that journey begins. If you've watched similar homemade welding videos before, this scene will likely feel familiar. I'm attaching one port of a single-phase metal coupling onto the threaded end of a spark plug, with the purpose of creating a solid connection between the plug and the homemade welding tip. At first glance, the setup looks simple, but structurally it's a smart and well-reasoned solution, taking advantage of the spark plug's precise threading, the mechanical strength of metal, and the flexibility to disassemble or adjust when needed. This combination allows the welding tip to stay firmly in place, ensures stable electrical contact, and makes the whole assembly suitable for real-world use rather than just a casual experiment. In my hand is a simple screw, and we're going to take advantage of its outer structure to turn it into a homemade welding tip. The first step is to clamp the screw firmly in a vise to ensure stability and safety during the process. Then use an angle grinder fitted with a metal cutting disc to remove the screw head. This cut creates a clean, controlled surface and establishes the basic shape of the welding tip. Next, we'll use a suitable length of electrical wire to connect the welding tip to the power source, ensuring a stable and continuous flow of current during operation. The wire should have an adequate cross-sectional area to handle the load, intact insulation, and a firm connection to the welding tip to prevent loose contact or unwanted sparking, allowing the system to operate safely and efficiently. To better protect the electrical connection and keep the assembly neat, I'll use tape to secure part of the wire along the body of the spark plug. This helps reduce direct strain on the contact point, prevents the wire from loosening during use, and keeps it properly positioned, minimizing unnecessary movement and improving the overall stability and safety of the homemade welding tip. Here we have a PVC pipe, perfectly suited to serve as the handle for the homemade welding machine, offering a comfortable grip for easy control. You can adjust the length or diameter to match your hand, ensuring better maneuverability and a more comfortable hold during use. This handle not only provides safety but also enhances the working experience, allowing you to control the welding tip with greater precision and stability. To securely fix the spark plug inside the PVC pipe, we'll use tissue paper, wrapping it around until the plug is held firmly without wobbling. This method takes advantage of the paper's slight elasticity to provide just enough grip, while remaining easy to adjust if necessary, ensuring the welding tip stays stable and safe during use. It's a simple yet effective solution to reinforce the integrity of the homemade handle. In fact, simply wrapping tissue paper isn't enough to securely hold the spark plug inside the PVC pipe. Therefore, we'll use liquid glue to increase adhesion and keep the plug firmly in place. The glue seeps into the small gaps between the plug and the pipe, creating a strong bond while still allowing for neat assembly. This ensures that the homemade welding tip remains stable and doesn't shift during use, improving both safety and reliability of the entire device. With the remaining end of this wire, we'll attach a crocodile clip to connect directly to the positive terminal of the power source. This setup allows for quick, secure, and flexible connections, ensuring a stable current flow from the source to the welding tip. The crocodile clip also makes it easy to disconnect or reposition the device when needed, enhancing both convenience and safety during use. Of course, another simple but essential tool is a wire with two crocodile clips attached at each end. This wire will connect to the negative terminal of the power source, completing the necessary circuit for the welding tip to function. The two clips allow for quick, secure, and flexible connections, while making it easy to disconnect or reposition the device as needed, ensuring stable current flow and safe operation during use. A small battery is my top choice to provide a suitable power source for this homemade welding device. Compact yet capable of delivering a stable current, the battery allows the device to operate effectively without the need for a large, complex power supply. It's a simple, convenient, and safe solution, ideal for experiments, small repairs, or DIY projects at home. The electric arc reaction is clearly visible when the positive and negative terminals of the power source come into contact. This is a clear sign that the homemade welding project has succeeded. However, to allow you to judge the actual performance for yourself, I will remain silent and conduct two small tests. So make sure to watch until the end, as you'll witness the device in action firsthand. Alright, so both tests have been successfully completed. This outcome is not only proof of the effectiveness of the homemade device but also a reward for patience, precision, and the creative spirit invested in every step. Every detail, every connection, every action contributed to this success, and this hands-on experience will give you greater confidence when taking on similar projects in the future.